Hubble Space Telescope celebrates 30 years of discoveries and awe-inspiring images. The Hubble Space Telescope launched 30 years ago on Friday, forever changing the way we see the universe. The telescope's ethereal, dreamy and almost fantasy-like views of space vistas have inspired people for decades and led to some of the most important astronomical discoveries. The Space Observatory and its instruments, an international cooperative effort between NASA and the European Space Agency, captures unprecedented views of stars, galaxies in the distant universe in visible, ultraviolet and near-infrared light. These different wavelengths of light have allowed Hubble to peer into different regions of space that had never been observed before. It orbits the Earth from a distance of 340 miles, well above the distorting effects of Earth's atmosphere for observing space both near and far. Hubble gave us a new sharp clarity in our view of deep space, said Jennifer Wiseman, Hubble's senior project scientist at NASA's Goddard Space Flight Center in Maryland. And that came about simply because Hubble was placed above the atmosphere of the Earth. This has given us a new vantage point for viewing everything in the universe from the nearby solar system to distant galaxies, and opened our eyes to the richness of the content of the universe and dynamic activity of the universe over time. The telescope was named for pioneering astronomer Edwin Hubble, who discovered in the 1920s that distant clouds in the universe were actually galaxies. He died in 1953. Hubble relied on the work of astronomer Henrietta Swan Leavitt's discovery of the periods of brightness in pulsating stars called Cepheid variables. Hubble's work led to the revelation that our galaxy was one of many, forever changing our perspective and place in the universe. Hubble continued his work and discovered that distant galaxies appeared to be moving rapidly, suggesting that we live in an expanding universe that started with a Big Bang. One of the main reasons for building Hubble was to be able to measure more precisely the expansion rate of the universe, Wiseman said. By Hubble's ability to observe activity in distant and faint galaxies, we've been able to measure that expansion rate. We're still refining it. In recent years, Hubble, along with others observatories, was a major contributor to the discovery that this expansion rate is accelerating, and that was a surprise. We now call the phenom behind this dark energy. This detection of the universe's expansion rate helped lead to the 2011 Nobel Prize in Physics, awarded to Saul Perlmutter, Brian P. Schmidt and Adam G. Rees, for the discovery of the accelerating expansion of the universe through observations of distant supernovae. Over 30 years, Hubble has enabled astronomers around the world to study black holes, mysterious dark energy, distant galaxies and galactic mergers. It has observed planets outside of our solar system and where they form around stars, star formation and death, and it's even spotted previously unknown moons around Pluto. Hubble has characterized the atmospheres of exoplanets and spotted weather shifts on planets in our own solar system. And it's looked across 97% of the universe, effectively peering back in time. The telescope was expected to last for 15 years, and it's still going strong. But Hubble was also designed to be serviced and upgraded over time. Between December 1993 and May 2009, astronauts launched on the Space Shuttle and rendezvoused with the telescope to make repairs and replace gyroscopes and instruments. The first one, in 1993, helped fix Hubble's infamous mirror flaw that was causing blurry images to be returned by the telescope. Astronauts installed corrective optics and new instruments to fix it. Each mission, which took years of planning and preparation, required the astronauts to leave the shuttle and conduct spacewalks to and inside a component of the telescope for repairs and installing instruments. All while the telescope moved at 17,000 miles per hour at an incline 28.5 degrees to the equator around the Earth. It shows me how all of us can all work together to make something fantastically successful and gratifying for humankind, Wiseman said. She has worked on Hubble in various roles for 20 years. Discoveries, expected and unexpected. In 1994, Hubble had the chance to watch a violent event in our solar system. The comet Shoemaker-Levy 9 was unexpectedly drawn into a collision with Jupiter, and the comet was pulled apart into fragments. Astronomers saw 21 pieces of the comet hit Jupiter, leaving temporary black scars within the planet's iconic clouds. They had never seen anything like it before. This was an astounding realization that solar system bodies can interact in very energetic ways, and that maybe our solar system isn't a completely safe place to be, Wiseman said. Since then, Hubble has given us a dramatic show of how planets in our solar system have weather changes, how asteroids can actually collide with each other, how moons of planets in our solar system can show activity and signs of water, and basically how our solar system might in fact compare to other star systems. Hubble also spotted 4 moons orbiting Pluto that had never been seen before. Nix, Hydra, Kerberos and Styx. The telescope also helped scout out a distant Kuiper Belt object named 2014 MU69, 1 billion miles beyond Pluto. In 2019, it became the most distant object ever visited by a spacecraft when the New Horizons mission flew by it. Now, the object is known as Erecath. Outside of our solar system, Hubble has explored our Milky Way galaxy and neighboring galaxies. The dramatic colorful images Hubble is known for are largely of active nebulae in our galaxy, bright clouds of gas and dust where stars are forming. In 1997, a servicing mission installed NICMOS on Hubble, the near-infrared camera and multi-object spectrometer. This new instrument allowed the observatory to peer through the thick gas and dust surrounding star nurseries and galaxies, where the stars emit infrared light. Roger Thompson, the lead for NICMOS and an astronomy professor in the University of Arizona's Stewart Observatory, began working on the proposal for the instrument in 1984. It shaped the future of infrared astronomy, from revealing secrets of star formation to looking back at the earliest galaxies in the universe. We could see down into these dusty regions where stars are being formed in all the exquisite detail with Hubble, Thompson said. And we were able to trace star formation in the history of the universe, way back to the earliest galaxies, which were only a few % of the age of the universe when they formed. In near-infrared, seemingly blank parts of sky appeared to light up with the evidence of distant galaxies, and no one expected that, Thompson said. Astronomers found that many young stars have disks of dusty debris swirling around them, where planets form. When Hubble was launched, in 1990, no one knew about a single planet outside of our solar system, said Tom Brown, the Hubble mission head at the Space Telescope Science Institute in Maryland. Astronomers found exoplanets in the 1990s using other telescopes, but Hubble was able to do groundbreaking science by following up on those observations and study exoplanet atmospheres. Hubble's firsts in exoplanet science include measuring another planet's atmosphere, confirming the oldest known exoplanet, detecting the first organic molecule on an exoplanet, and the first changes in an exoplanet atmosphere. Today, exoplanet science accounts for 20% of the telescope's observational time. The telescope has enabled the mapping of dark matter, even though dark matter is invisible. Dark matter is a mysterious substance that makes up most of the matter in the universe, but we don't know what it is and can't observe it because it doesn't emit observable radiation, Wiseman said. But we know it's there because of gravitational effects. Hubble is being used to map out where dark matter is and its effects through gravitational lensing. Gravitational lensing has also allowed Hubble to look deeper into the early days of the universe. It occurs when clusters of galaxies create a distorting gravitational field that acts as a natural, giant magnifying glass for the distant galaxies beyond Hubble's viewing capability. Hubble also enabled astronomers to realize that galaxies tend to merge with one another, capturing dramatic images of these mergers unfolding across the universe. That's how our own Milky Way galaxy grew to its current size, through merging with smaller galaxies. And Hubble is credited with helping astronomers realize that supermassive black holes are ubiquitous with centers of giant galaxies. Hubble was able to observe gas falling into galactic centers near the speed of light, which is now considered a fundamental understanding, Brown said. Thinking about universe as a whole, I believe Hubble opened our eyes to the recognition that galaxies have changed dramatically over cosmic time, Wiseman said. The future of Hubble. Hubble scientists believe that the telescope will keep operating through at least 2025, if not longer. This provides astronomers with an excellent opportunity because Hubble can overlap with new space-based telescopes coming online soon, like NASA's James Webb Space Telescope, set to launch in 2021. Webb is an infrared observatory. Together, their combined capabilities can provide a more complete picture of targets they observe. Webb will provide a more detailed look at exoplanets and their atmospheres and peer deeper into the earliest days of the universe than ever before. Hubble continues to contribute to incredible discoveries and follows up on the detections and observations of other telescopes. For years, Hubble has been the perfect complement to NASA's other great observatories, including the Chandra X-ray Observatory and the recently retired infrared Spitzer Space Telescope, as well as ground-based observatories. It's been used to follow up on detections of gravitational waves and the explosions of neutron-star collisions by LIGO and Virgo, which are gravitational wave detectors. And Hubble has actively followed the journeys of interstellar visitors passing through our solar system, like the interstellar asteroid Oumuamua in 2017 and interstellar comet 2I Borisov, which is still here. We're getting a better scientific return now than ever before, Wiseman said. I'm excited about how it will be used in coming years for new discoveries and in complement with newer observatories. But when Hubble's mission does come to an end, its optical and ultraviolet capabilities won't be reproduced anytime soon. The only thing similar is LUVOIR, the Large UV Optical IR Surveyor. This concept is for a multi-wavelength space observatory that, if developed, may launch in the late 2030s or 2040s, Brown said. Depending on when Hubble concludes, this could leave a massive gap for scientists who depend on Hubble's observations to do their work. And when it comes to Hubble observations and its incredible images, there's no other game in town, Brown said. Hubble has provided 1.4 million observations over 30 years, fueling more than 17,000 peer-reviewed scientific publications with its data, making it the most prolific space observatory in history, according to NASA. And Hubble's archival data will provide a wealth of scientific opportunity in the decades ahead. For now, they have hope that the telescope will continue on for years, and maybe even decades, to come. It's aging in a very graceful, well-understood way and operating just as powerful as ever, Brown said. Click subscribe to receive the latest news.